Hello and welcome to yet another video of Cornerstones of Math. This is a rather short video about very easy problem. The problem is, for a sequence an, if the limit of 4an minus 3 divided by 2an plus 1 as n goes to infinity equals 1, find the limit of an as n goes to infinity if it exists. Like I said, this is a very easy problem which I think many of you can find the answer in no time. However, what I want to ask you in this video is not can you solve this problem, but rather do you know the correct way to solve this problem? So I will show you the wrong method first. We want to find the limit of an, so naturally we substitute limit of an with a simpler expression, say alpha. Then we have the following famous properties of limits, which I believe you are all very familiar with. These properties basically state that we can sort of split the limits in terms of multiplying real numbers, addition and subtraction, multiplication, and division. Combining these properties, we know that the limit of 4an minus 3 divided by 2an plus 1 equals 4 alpha minus 3 divided by 2 alpha plus 1, and this must be equal to 1. And you can easily solve this to obtain alpha equals 2, which must be the value of the limit of an. However, this method is wrong. More specifically, the answer itself is right, but the logical process is wrong, meaning that if this problem was on a test where you must provide a logical process in detail, for example, like many tests in a college, you would get no points if you use this method. The reason why this is wrong is because the above properties of limits are applicable only if we know that sequences an and bn converge. In other words, their limits exist. But it is not given in the problem that limit of an exists, meaning that we cannot apply these properties straight away. I can even give you a counterexample where the limit of rational expression of an exists, even though the limit of an does not exist. If an equals just n, and if you consider the limit of the same rational expression, you can easily realize that the limit of an does not exist, but the limit of 4an minus 3 over 2an plus 1 exists, which gives the value 2. So what is the logically correct way to solve this problem? The correct method. First, let us substitute the entire rational expression with bn. Then it is given in the problem that the limit of bn as n goes to infinity is 1. Now let's solve for an. So first we obtain 4an minus 3 is equal to bn times 2an plus 1. So if we expand the right hand side, then the right hand side becomes 2an times bn plus bn. And if we move every an term to the left-hand side, we have 4 minus 2bn times an equals bn plus 3, which gives an equals bn plus 3 divided by 4 minus 2bn. And here's the important thing. Since we know that the limit of bn exists, now we can apply the aforementioned properties of limits. That is, when calculating the limit of an, hence the limit of this rational expression, now we can directly plug in the limit value of bn, which gives the answer 2. Again, please remember that these properties of limits are applicable only if we know that these limits exist. And that's all for today's video. Now here are some other cases where students are prone to make mistakes in terms of mathematical logic, so feel free to check out these videos as well. Also, please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.